All right, so today we're covering multiplying, adding, and subtracting rational expressions. Remember that rational expression is just a fraction where the numerator is a polynomial and the denominator is also a polynomial. Okay, so basically you're looking at a fraction with some variables in the mix. Now, the first example I have here is very simple, just multiply. Starting off easy, we have monomial over monomial times monomial over a monomial. Now the idea that we want to use here for simplifying, because that's what we're going to be able to build on later on, is to simplify by factoring completely. So really, essentially, right, multiplying, remember when you're multiplying fractions, you multiply straight. So this is just 4a squared times 15 over 5 times 20a to the 5th power. So let's go ahead and factor the numerator completely. So 4 would factor into 2 times 2, and a squared is just 2 copies of a multiplied together. 15 is 5 times 3. And I'll just extend that fraction bar. Now, in the denominator, 5 can't be factored any further, so I'll just leave it like that. 20 is 4 times 5, and 4 is 2 times 2. So 20 is 2 times 2 times 5. And then a to the power of 5, of course, is just 5 copies of a multiplied together. And I will extend the fraction bar here. Now, the idea, if you remember from the other video, is to cancel out common factors. Okay, so if you have it's the same factor, for example, like we have a in the numerator and we have an a in the denominator. Well, a divided by a is just 1, so it cancels. We have another copy of a that would cancel. We have 5 divided by 5 that would cancel. We have 2 divided by 2 that would cancel. 2 divided by 2 that would cancel. And those are the only common factors in the numerator and denominator. So what we're left with in the numerator is just a 3, and in the denominator 5 times a times a times a, which would be 5a cubed. Now, if you remember from the previous video where we did simplifying proportions, what you want to do is include any excluded values, right? So if you have a value, a variable in the denominator, you have to say what value that variable cannot be, because then it would make the entire denominator of the fraction 0. So a cubed, a could not be 0, because then 0 cubed will be 0, 0 times 5 would be 0, and that would make the entire denominator 0. So that has to be a part of your answer if you have any variables in the denominator. Okay, so let's do another example. Now, these examples, obviously, we kicked it up a notch because over here we just had monomials for our fractions. Now we're looking at a trinomial over a trinomial times trinomial over trinomial. But the idea is still the same. So you essentially, since this is multiplying, right, really this is all of the fraction, this trinomial times this trinomial over this trinomial times this trinomial. Now you might, like, when you're thinking, oh, let's multiply this, let's go ahead and distribute things out. But that's actually the opposite of what we want to do. The easiest way to do this is going to be by factoring first, right? So same idea like we did over here, we're going to simplify and multiply these two together by actually factoring and canceling out any common factors that are in the numerator and denominator. So let's go ahead and do that. And what I'm going to do is I'm just going to factor each trinomial separately, right? So this is going to be the numerator over the denominator, and this trinomial, right, since the coefficient of all of these trinomials is just 1, it makes factoring really easy. We're just looking for the numbers that multiply to c and add to b. So what multiplies to 6 and adds to 5? Well, 2 times 3, 2 plus 3. So this would factor into x plus 2 times x plus 3. And then on this trinomial, right, we're looking for two numbers that multiply to -4 and add to 3. So that would be 4 times -1, 4 plus -1. So this will factor into x plus 4 times x minus 1. In the denominator, we have first on the left this trinomial multiplies to negative 20, adds to negative 1, negative 5 times 4, negative 5 plus 4. So this will factor into x minus 5 times x plus 4. And then lastly, this trinomial, we're looking for multiplies to negative 2 and adds to positive 1. So that would be x minus 1 times x plus 2. All right, now that we have that completely factored, we can now state our excluded values, right? So what values of x cannot be possible because that would make this denominator 0, right? Now all of these are multiplying together, so if any one of these separate factors equals 0, then 0 times anything would be 0, so if any one of the factors was 0, that would make the entire denominator 0. So x cannot be 5, negative 4, 1, or negative 2. Now that we have our excluded values, let's go ahead and cancel out any common factors on top and bottom, right? X plus 2 divided by x plus 2 would cancel. X plus 4 divided by x plus 4 would also be 1 and cancel. X minus 1 divided by x minus 1 is 1 and that would cancel. Remember that you can cancel out any common factors in the numerator and denominator. Factors only, not terms. And also, it has to be the same exact factor. So if I had, for example, in the numerator was x plus 4, but the denominator was x minus 4, that wouldn't cancel. Okay? So we end up with only x plus 3 in the numerator and x minus 5 in the denominator. And again, x is just a term here, right? The factor would be x plus 3. So you can't cancel out term only. So you can't cancel out the x because that is the term, not the factor. Okay? All right, let's do another example. So here we have, again, just, in this case, it's a binomial over a binomial times binomial over binomial. Now, you do have, right, multiplying, so this binomial is multiplying to this binomial, and this binomial is times this binomial. So let's go ahead and apply the same idea as before. Let's factor each of these separately. So this is the difference of squares, right? So that would factor into x plus 5 times x minus 5. And from here, I could factor out an x from both of these. So that will factor out, and I would get x minus 4. All right, on the bottom here, that's also the difference of squares, so that'll factor into x plus 4 times x minus 4. And right here, I could factor out a 2, and that would leave me with x plus 5. All right, let's go ahead and write our excluded values. X cannot be negative 4, positive 4. Now this 2 doesn't have a variable, so that doesn't give me any excluded values, but x plus 5 will give me x equals negative 5, so x cannot equal negative 5 either. Okay, now let's go in and cancel out any common factors, right? So we have in the top, we have x plus 5, which cancels out with x plus 5, and then we have x minus 4, which cancels out with x minus 4. And that's it. So in the numerator, we have x times x minus 5, and in the denominator, we have 2 times x plus 4. Now, you can't leave it like that, right? Now that you've canceled out all of the factors that are possible, you have to finish simplifying by now multiplying whatever remains. So my final answer would be x squared minus 5x over 2x plus 8. All right, so go ahead and pause the video and try number 3 on your own. Okay, so hopefully you were able to try that one, and let's see how you did. So what you would do for this one is you would, in the numerator, right, we still have, now it's going to be this trinomial times this binomial, and in the denominator we have this binomial times this binomial. And again, don't actually multiply them in. Go ahead and use the strategy of factoring out and then canceling out common factors, right? So this trinomial here multiplies to 9, since the coefficient is 1, multiplies to 9, adds to 6, would be 3 times 3, 3 plus 3. So this is x plus 3 times x plus 3, or x plus 3 squared. And then here I could factor out a 3, and I get x squared minus 9. Now this is the difference of squares, so I could actually factor that further into x plus 3 times x minus 3, but I'll leave it like that for now. And then I could factor out from here a 2, and that gives me x squared minus 9. So actually, you can see there that both of these are x plus 3 times x minus 3, so those will cancel. And then I could factor out 2 from these, which give me x plus 9. So let's go ahead and write our excluded values, right? So x cannot be positive 3 or negative 3 because of this factor, and x cannot be negative 9. From there, I could see that I could I can cancel out the common factor of x squared minus 9, and that's it. So in the numerator, we have this trinomial times 3. So that would be 3x squared plus 20. 3 times 6, no, is 18. And I'm just using the previous trinomial. Like, I know these two multiply together will be this, so I'm just distributing 3 to all these 3 terms. So 3 times x squared will be 3x squared. 3 times 6x is 18x. 3 times 9 is 27. In the denominator, we have just 2 times 2 times x plus 9. So 2 times 2 would be 4, and then distributing 4 to both of the terms, 4 times x is 4x, 4 times 9 is 36. And that is our final result, simplified as much as possible. All right, let's move on to adding and subtracting, right? So again, let's start simple. What is the basic idea with adding and subtracting fractions? Well, you need a common denominator, right? Now, normally what we do is we have numbers only. So we can very easily manipulate and think about those numbers and say, okay, well, what do I have to multiply to get the denominators to be the same, right? With polynomials, right, when you have rational expressions, the easiest way to do this is actually going to be to factor the denominators for both of them. And then once you have it completely factored, you can see which factors are missing from the denominator to get them to be the same. So let me show you what I mean. And again, the numerator of your fractions, when you're adding and subtracting, right, it doesn't matter. The denominator is what has to be the same. So that's what you want to factor. So 10 would factor into 2 times 5, and 15a would factor into 3 times 5 times a. Okay, so now this is what I'm talking about. You could see here that we do already have a common factor of 5, right? However, the 3 and the a is missing from this denominator. So that means that I'm going to need to multiply that 3 times a into this denominator so that both of those show up in this denominator. Now, in this denominator, what we have missing is a factor of 2. So I'm going to need to multiply this fraction by 2. Now you can see that we have 2 times 5 times 3 times a. So the denominator will be the same on both now. Okay, so now we're going to simplify. 3 times 3a would be 9a. The denominator here, 2 times 5 times 3 times a would be, 2 times 5 is 10, and 10 times 3 is 30, so this would be 30a. And then 8 times 2 is 16, and again, the denominator here is the same. We have all of the same factors multiplied together, so that would also be 30a. Remember, for adding and subtracting, once you get the denominator to be the same, it stays the same for your answer, and you just add the top. So the numerator is going to be 9a plus 16. Okie dokie. And that is our final result. And again, As long as you have a variable in the denominator, you have to state what value that variable cannot be. So a cannot be 0. And that is a part of the answer, okay? All right, so let's get a little bit more complex here. I have x over 3x squared minus and then we have a 3 that we're also missing for this denominator. And in this denominator, we're missing a factor of 2. So I have to multiply a factor of 2 in. So we have x times 2, which is 2x. And then in the denominator, 3 times 2 is 6x squared. 5 times x times 3 would be 15x. And 2 times x times 3 would give me 6x squared. Now that this denominator is the same on both, it stays the same for my answer. And I just do the top. 2x minus 15x would be negative 13x. Okay? And obviously we have a copy of x that we could cancel. So let's cancel out one copy of x, which would cancel out with one copy of x here, leaving me with one copy of x in the denominator. So we end up with negative 13 over 6x. And I put that negative to the entire fraction. You could just leave it on the numerator. Negative 13 over 6x is also correct. Or you could even move that negative to the denominator, which would be 13 over negative 6x. Okay, so any of those would be correct. Usually for answers, you would just bring out the negative to the front of the fraction. All right, so go ahead and pause the video and try number 2 on your own. Okay, so here we're missing a copy of 2, right? A factor of 2 for the second fraction. So this is 3 over 2x minus 2 over 2x. So I didn't really have to do a whole bunch of multiplying here. We were only missing a factor of 2 for the second fraction. So now that the denominator is the same, it stays the same for my answer. And then 3 minus 2 is 1. So we get 1 over 2x. And one tiny thing that I forgot, so be careful, do not forget, right? Excluded value, x cannot be 0. And I forgot on why I was saying that I forgot was for the previous problem, I did not mention or put in as a part of my answer, so that would have been wrong. I need to put in x cannot be 0, right? And no matter which one of these fractions you write, you do have to include that x cannot be 0. All right, so let's get a little bit more complex here. Now we have a binomial, right, in the denominator. Now, the binomial in the denominator here is x minus 4, and the binomial in the denominator here is x minus 4. So they're already the same, right? So we don't have to do any of that multiplying because the denominator is already the same, so it's going to stay the same for my answer. And the numerator, we have x squared minus 8x minus 16. And again, remember, whenever you have subtracting, make sure that you distribute that negative to all of the terms. So if there was only one term, right, if it was just 8x, then it would just be x squared minus 8x. But there's 2 terms, so you have to distribute the negative to both. So it's minus 8x plus 16. All right. Now, normally we might think, oh, well, we're done here. But we have to see if I factor this, would x minus 4 cancel? So let's go ahead and factor the numerator. The coefficient is 1, so this is easy factoring. Again, multiplies to 16, adds to negative 8. Let me think here. Multiplies to 16. Well, 1 times 16 wouldn't work. 2 times 8 wouldn't work. 3 times 3 is not a factor. 4 times 4. Yep. Negative 4 times negative 4, negative 4 plus negative 4. So this is actually x minus 4 times x minus 4 over x minus 4. So you could see here the denominator x minus 4, that will actually cancel, right? So let's write our excluded values before we forget to do that. X cannot be 4. And then x minus 4 would cancel with x minus 4, so we end up with one copy of x minus 4 in the numerator. All right, so let's move on to number 2. Now, number 2 is a little tricky because it almost seems like these two are the same, right? You have x minus 5 and then you have 5 minus x. But remember that subtraction is not commutative, right? So if you have 2 minus 3, that would be negative 1, versus 3 minus 2 would be positive 1. So subtraction, if you change the order, those two are not the same, right? So x minus 5 is not the same thing as 5 minus x. So how are we going to get these two denominators to be the same? Now, the first thing that I would suggest is if the variable is not in the front, that's what you want to do first. Get it in standard form. So I'm going to just switch these around. The term negative x, write that first, and then the positive 5, write that second. So these two are the same. I'm just rewriting it so that the variable is in the front. Now we can see that the difference here is that the x is negative and the 5 is positive. Over here, the x is the one that's positive and the 5 is negative. So if I just factor out an x, it would, a negative, excuse me, if I factor out a negative 1, it would make the denominators the same. So let's go ahead and do that. So I'm going to factor out a negative from both of the terms in the denominator, leaving me with x minus 5. And then what I'm going to do is I'm going to bring that negative to the fraction so that it's no longer in the denominator. That way in the denominator I just have x minus 5. So I end up with 3x over x minus 5 minus 7 over x minus 5. Right? I just brought that negative to the entire fraction. That way it would get rid of the negative from the bottom. Now that the denominator is the same, it's going to stay the same for my answer. And in the numerator, we just have 3x minus 7. Okay? Now I can't factor the numerator, so there's no possibility to cancel out the x minus 5. So this is as simple as it can get. And we do have to include, of course, x cannot equal 5. All right, so let's try one more that's a little bit more complex. So we're actually going to have to multiply things in, right? So I have 4x in the denominator of the first fraction, and I have x minus 1 in the denominator of the second fraction. Now, no matter how I shape this, I'm going to have to multiply this fraction by 4x, because I am missing 4 and x as factors. And I'm going to have to multiply this fraction by the factor x minus 1, because that's missing from the first fraction. Okay, so I'm going to have here in the denominator 4x times x minus 1, and I do suggest to leave the denominators factored, right? I have that note right here. Leave the denominators factored, because eventually when I combine the numerator, right, I will need to factor it to see if there are any factors that cancel. So if you already leave it factored, you don't have to multiply it and then factor it again when you're trying to see if there are any factors that cancel. So leave the denominator factored, okay? Just multiply the top, that way you have terms that you can then combine in the two fractions, right? So go ahead and simplify the top, but leave the bottom factored. So x minus 1 times 6x minus 4. X times 6x would be 6x squared. X times negative 4 would be negative 4x. Negative 1 times 6x would be negative 6x. Negative 1 times negative 4 is positive 4. On the second fraction, we have the same denominator, right? The 4 times x minus 1. And in the numerator, we have 4 times 4x, which would be 16x. So now that the denominator is the same, right, it stays the same for my result. And then in the numerator, I'm just going to add these two numerators together, right? All of this plus 16x. So I can obviously combine the negative 4x minus 6x plus 16x. So negative 4x minus 6x would be negative 10x, and then plus 16x would be 6x. So we end up with 6x squared plus 6x plus 4. All right. So now let's go ahead and factor that numerator now that it's completely simplified and we have just one fraction. Now that we have one fraction, factor the numerator and then see if there are any common factors that will cancel. So to factor the numerator, I'm going to actually do that just on the side over here so that I don't run out of space. So I'm just going to factor this numerator here on the side. Okay, the first thing is I see a GCF of 2 that I could factor out, right? So I could factor out 2 from all three terms, which would give me 3x squared plus 3x plus 2. And the coefficient is not 1, so I will have to rainbow over. I need a number that will multiply to 3 times 2, which is 6, and will add to the middle coefficient, which is 3. So what two numbers multiply to 6 and add to 3? Okay, now there actually isn't anything that will multiply to be 6 and add to be 3, right? The only things that multiply to 6 would be 1 times 6. That obviously doesn't add to 3, and even 2 times 3 would not add to 3. So there isn't anything. So the numerator will only factor as much as the GCF factoring out 2, which gives me the 2 times 3x squared plus 3x plus 2. In the denominator, we have 4, which is actually 2 times 2, times x minus 1. So the only GCF, the only factor that cancels here would be the 2. So the excluded values for x would be x cannot be 0 and x cannot be 1. And then the numerator would simplify to just 3x squared plus 3x plus 2. And the denominator would be 2x times x minus 1. So 2x times x would be 2x squared, and then 2x times negative 1 would be negative 2x. And that would be our final answer. Oops. Okay, let's go ahead and try one more, and then you can try 2 and 3 on your own. So here we have 4n squared minus 4. Now I could factor out the GCF of 4. That gives me n squared minus 1. And n squared minus 1 would factor to n plus 1 times n minus 1. So this denominator completely factored would be 4 times n plus 1 times n minus 1, right? Now, clearly here we're missing a factor of 3 in that first fraction, and we're missing also a factor of n. We have 4, we have n plus 1, and we have n minus 1. So we're missing, for the first fraction, we're missing 3 and n. So I'm going to multiply that to the top and the bottom. And on the second fraction, we're missing 4. We're missing the factor n plus 1, and we're also missing the factor n minus 1. So we're missing the entire denominator. For the numerator, I'll write it as 4n squared minus 4, because I'll actually need to combine the numerators, and it's going to be easier to do that if I have it in the simplified form, not in the factored form. But for the denominator, right, since the denominator is really going to stay the same, once you get the denominators to be the same, they stay the same, and you want to leave it in factored form, I will multiply 4 times n plus 1 times n minus 1. Of course, 4 times n plus 1 times n minus 1 is 4n squared minus 4, so really I'm multiplying by the same thing on the top and bottom. I'm just multiplying the simplified version of that on the top, while I'm multiplying the factored version on the bottom, because in the denominator, we're going to keep that denominator in the factored way. So 3 times n times 4 times n plus 1 times n minus 1. In the numerator, this is where I'm going to simplify. 3n times 4 is 12n, and that will add with 6n times both of these terms. So 6n times 4n squared would be 24n squared, and no, I'm sorry, n times n squared would actually be n cubed. And then 6n times negative 4 would be negative 24n. Now, this is where I need to use my knowledge of factoring from last section, right? So I need to use my knowledge of factoring. First, I'll combine both of these together. Okay, so 12n minus 24n would be negative 12n, so the numerator would simplify to 24n cubed minus 12n. And the denominator is just going to be 3 times 4 times n plus 1 times n minus 1. Right? Now the numerator, let's go ahead and just erase and factor this as we go along. So we could factor out 12n, which would leave 2n squared minus 1. So we could factor that. We could factor out 12n, and that would leave 2n squared minus 1. And that's as much as that can factor, right? I can't factor n squared minus 1 any further. This is not the difference of squares. It's not the difference of cubes or any other thing that would be factorable. So now we're going to go in and write our excluded values before we cancel out any common factors. So n cannot be 0, n cannot be negative 1, and n cannot be positive 1. Now from here, actually, I could have factored 12 is 4 times 3, right? So this is actually 4 times 3, or 3 times 4, same thing. And you could see now that we could cancel out 4, we could cancel out 3, we could cancel out n, and that's it. So in the numerator, we are left with 2n squared minus 1. In the denominator, we have n plus 1 times n minus 1. So this is actually the n squared minus 1, right? If I multiply it together. So that would simplify if you multiplied it together to n squared minus 1. So always remember the process is first, get the denominators to be the same so that you can combine the numerators and have one fraction. Then once you have that one fraction, you factor the numerator. The denominator will already be factored because you needed to factor it to see what factors were missing so that you could multiply and get the denominators to be the same. So leave the denominator factored. Once you simplify and combine the numerator, then go ahead and factor the numerator and see if there are any common factors then at that point that you can cancel out so you can completely simplify. Once you've canceled out all common factors, then you go ahead and multiply whatever remains in the numerator together and multiply whatever remains in the denominator together. And don't forget to write your excluded values. All right, so pause here and try 2 and 3 on your own. Okay, so let's go in and do these problems, and you can fast forward to the answer to see if you got it correct, and you might not need the explanation, but if you didn't get that correct, then here's the explanation of how to do this problem. So we have 4, which of course 4 is 2 times 2 times x. 4x is 2 times 2 times x. So in the second fraction, you have x plus 5. So you're missing x plus 5 factor in the first fraction. So I need to multiply by x plus 5. And in the second fraction, you're missing the 2 times 2 times x. So you're missing a factor of 2, another factor of 2, and the factor of x. So I'm going to multiply by the factored form in the bottom because I want to leave the denominator in the factored form. And then I'm going to multiply by the simplified version in the numerator because I will actually need to multiply this out so then I could combine the numerators, right? The denominator will just stay the same, so it'll be the 2 times x times x plus 5, and then the numerator of this fraction will be 3 times x times plus 3 times 5, So it'll be 3x plus 15. And then we are subtracting here. So be careful. Remember, when you're subtracting, whatever is after it is in parentheses, and you need to distribute the negative to both. So 4x times x would be 4x squared, and 4x times 4 would be 16x. So really this is minus 4x squared minus 16x, right? So the numerator, if we simplify it completely, will be 3x minus 16x, which is negative 13x, negative 4x squared, and positive 15. And I wrote that in standard form so that I could easily factor on the next step. The denominator, again, we're just going to leave it factored. You kind of don't mess with the denominator until you factor the numerator, and you can see what cancels, right? So now let's go ahead and factor that numerator. Now again, first things first, I would always suggest factor out a negative. That's going to make factoring easier. If the front number is not a positive, factor out a negative. And then you can rainbow over, right? So 4 times negative 15, so we're multiplying to negative 60 and adding to 13. All right, let's see if I look up some numbers here. So multiplies to negative 60 and adds to 13. So in order to multiply to a negative, we would have to have a positive and a negative. So that would essentially, when you add them, they will subtract, right? Because you're going to have a positive and a negative. So we're looking for two numbers that multiply and then essentially subtract to 13. So 20 divided by 2, 30 and 2 don't work. And then I'm going to try the next number, 60 divided by 3, 20 and 3 wouldn't work. Let's try 4. 4 times 15, that would subtract to 11, so that doesn't work. Let's try 5 next. That would subtract to 7, so that doesn't work. Now notice that we subtracted to 11 and then we subtracted to 7, so we've already missed the mark for 13. This is actually something that will not factor at all, so this is as factored as it gets. So I'm going to go ahead and get rid of that because we weren't actually able to factor that numerator. So essentially it will stay as it is. And you could either leave the numerator like this, or if you factored out a negative, then you can bring that negative to the front of the fraction. Is usually, if you have like multiple choice, it would show up like that as the answer choice. And then the denominator, we just need to multiply them all out. Actually, before I multiply them all out, let's go ahead and write our excluded values. X cannot be 0 or negative 5. And then in the denominator, 2 times 2 is 4, times x would be 4x. 4x times x would be 4x squared, and 4x times 5 would be 20x. So this is our final answer, because we weren't able to factor the numerator to cancel out any common factors on top and bottom. All right, number 3. So on number 3, we have here a plus 2, so that's obviously as factored as possible. The denominator here, we could factor out a 6. That would give me a plus 1. And so you could see here we have two factors, 6 and a plus 1. They're both missing from this one. So I'm going to multiply 6 and a plus 1. So essentially I'm multiplying by the factored version in the denominator, and then multiply the simplified version in the numerator, because you will have to multiply 4 to both of those. And then in this denominator, we are missing the factor of a plus 2. So I'm going to multiply a plus 2 on top and bottom. And again, you will have to simplify the numerator. The denominator, leave it in a factored form. So 6 times a plus 1 times a plus 2. And then the numerator here would be 4 times 6 is 24. So 24a plus 24. And then 2 times a, and this is adding, so it won't change the sign like with subtracting, right? You have to distribute the sign of both. Adding will not change the sign. So this is plus 2 times a plus 2 times 2, which is 4. All right, let's go ahead and combine now. We can combine 24a plus 2a is 26a, and 24 plus 4 is 28. And the denominator, again, I'm just going to leave that in the factored form. And I will need to factor the numerator. So a common factor of 26 and 28 is, let's try 2. So if I factor out 2, I would get 13a plus 14. And in the denominator, it would be 3 times 2 times a plus 1 times a plus 2. So now that it's factored as much as possible, we can go ahead and write our excluded values. A cannot be -1 or -2. And we have a common factor of 2 that cancels on top and bottom. So the numerator is just 13a plus 14. And in the denominator, we have 3 times a plus 1 times a plus 2. So let's multiply 3 times a plus 1 first. So we have 3a plus 3. And 3a times a would be 3a squared. And 3a times 2 would be 6a. 3 times a would be 3a. 6a plus 3a would be 9a. And 3 times 2 is 6. So that is it. All right, hopefully you got those 2 right.